Hey Ema, let's just get back to this question. So the question, a couple of things about what you did. You worked out VA and VB correctly. The question asked you for VBA. So if it's VBA, then I would say it's VB minus VA. Otherwise, you're just going to get into sign difficulties. And when you do that, VB minus VA is minus, I think it was minus 31i. Minus 31i, I think that was, plus 0j, minus 24i minus 0j, minus 24j. And when you work it out anyway, that's what you should have got. Okay, so that's the first thing. The second thing now is that the question said, after finding VBA, let's see, it says, at noon, ship B is 300 kilometres south of A. So I'm going to draw a nice big diagram here. So B's down here, there's A. When you do your VBA is minus 7i plus 24j. So this is the direction, that kind of a direction, which means it makes an angle of, I'll call it alpha, with the I-axis. So if I were to put this vector in here now, right? I know that the angle it makes with the I-axis is this one here, alpha. So this is my vector's direction. So that's what I'm putting in there, VBA. I'm going to drop a perpendicular from B's position, which is 300 kilometres south of A. So I'm going to drop a perpendicular down here. And I'm going to be able, I know this distance from there to there is 300, it tells me that in the question, and I'm going to be able to find this angle inside in the triangle there. So by the opposite rule, this over here is alpha, which means that I'm going to call this angle in here theta. So I'll be able to find theta. So the sine of theta is equal to this closest distance, which I'll call for the time being x. So this sine theta is x over 300, and that allows me to get then the closest distance. So the closest distance in this particular case, I think we said it was 84, was it? Yeah, I think it's 84 that we said that was. I haven't got my calculator. Let me just put. Anyway, I think that was 84. Now remember how you know to get alpha. Remember alpha is arctan 24 over 7. So if you wanted to find alpha, you'd have the opposite over the adjacent, and opposite over adjacent is arctan. So I'm just going to pop that in, and that will give me an alpha of 73.74 degrees. So we have alpha. If we have alpha 73.74 degrees, that means we can find theta. So theta is 16.26 degrees. And then when I multiply the sine of that angle by 300, I will get my 84. So that's the closest distance, 84. That's the closest they're going to be to each other. Okay, now I'd get that anyway before I went any further, because you never know when you might need it. Right, now, the next part of the question says, A and B can exchange signals when they are within d kilometres of each other. Now, if I wanted to find out d, what I would do here, I'd come down. Now, this is my relative velocity line, VBA. So I'm going to come down to this position here, which is not on the relative velocity line. This is not on that relative velocity line. And I'm going to draw a circle around B, which is d kilometres in radius. I'm going to draw a circle like this. And I have no idea what this d is. Okay? But I do know that the distance from B to the relative velocity line is this distance d. So from here, from B, which is not on the relative velocity line, to where the circle cuts the relative velocity line, that distance is d. And from this position here, which is not on the relative velocity line, to where it cuts the circle, that is also d. So can you see now I have a triangle? So I have this triangle there, that line part of the triangle, which is the VBA line. And then I have D, and then I have another D. And of course I've got this distance here, which I now know as well. And this is a right angle because I've dropped perpendicular. So this is X. Right, now question says to me, these two ships can exchange signals for 2.8 hours. Now normally the time to exchange signals would be the distance divided by speed. Now, distance being relative distance divided by relative speed. So the relative distance and the relative speed, those two bits of information have to come from the relative velocity line, which is this VBA line. So that's here. So the distance from here to here has to be on the VBA line. So I'm going to call that maybe, because they're going to be exactly the same. This is a right angle. So looking at this triangle, that's a right angle, that's D. I'm going to call this X. This is a right angle, that's D. Sorry, not X, I'm going to call this Y. Can't get my letters mixed up. And if this is X and that's D, this is also Y. So those two sides, those two distances are the same. They're equal. So that means the relative distance on that relative velocity line is Y plus Y. So the whole, from there to there, is the relative distance. And the relative speed is the modulus of VBA. Now come back up here again. To find the VBA is minus 7i plus 24j. So to get the modulus of that, you're going to get the square root of minus 7 squared plus 24 squared. And the square root of the whole thing. And that works out actually at 25. So 2y over 25 is equal to the time from which they can exchange signals, which of course is 2.8. Now, when you work that out, you get 2y is equal to 2.8 multiplied by 25. I'm just going to look at the values here in the question. So when you work that out, I'll just see, I don't know what that works out at. So 25 multiplied by 2.8 gives me 70. So 70 is equal to 2y, which means that y is equal to 35. Okay, so I'm looking for d. I have y, I have x, so now I can find d. So I'm going to use Pythagoras. And that's going to say to me d squared is equal to x squared plus y squared. So I know what x is. X is 84 squared. And y, of course, is 35 squared. And when I do that, that'll give me, d will be the square root of that sum, and that will give me 91.